how to read one data sheet. Okay. One microcontroller. So it could be any microcontroller. Okay. So whatever the microcontroller datasheet, you can able to download it. So how to read it and what are the data which is very, very important for that datasheet. Okay. So that's what I'm going to be teach you on this complete live session. Okay. So today I just take you one microcontroller called as an STM32. Okay. So, if you are having any other microcontroller, if you are going to be take pick microcontroller 8051 or AV, so kind of anything you can able to take it and refer this. Okay. So today I'm going to be tell you the how to read your data sheet for STM32 microcontroller. Okay. So it will be look same for all the microcontrollers. So if you're trying to be read for one microcontroller, if you're trying to understand completely about one microcontroller, it is easy to look out for other ones also. Okay, so now we will see the first we will start to read the data sheet. Okay, and before you are going to be read the data sheet, you need to find the correct data sheet for your microcontroller. So that is the very, very important parameter, right? So if you want to be read any data sheet, first of all, you need to be you need to be get the data sheet. So then where can I able to get this data sheet? So you might be asked this questions. You can able to get the data sheet in DigiKey. Okay. So it can able to provide all the components as well, that specific data sheet for all the peripherals and all. Okay. And you can able to get the data sheet for the specific manufacturer. So this STM32 microcontroller was manufactured by ST Microelectronics. Okay. So through that website, I can able to get the data sheet. Okay, so the common website you can use for DigiKey website, you can able to get every data sheet in that website. You can able to get it, or specific. If you are just want to be get the data sheet for the specific microcontroller from specific company who manufactured that company, you can get this data sheet. Okay, so STM32 was developed by it is ST Microelectronics. You can able to get the data sheet through that website. So two things you're going to be keep it on the mind. So to get the data sheet, you are going to be get from DigiKey website. So inside this DigiKey website, you can able to get all the products, all the data sheets, everything you can able to get through this, or you can use the specific website who manufactured that specific microcontroller. For example, ST Microelectronics, who manufactured the STM32 board. So I just directly go to their website, and here also I can able to get all the datas, IDs, everything I can able to get it. Okay. So through two ways you can able to get the data sheet. So this is how you are going to be get one data sheet. Okay, I hope you got clear on this point. And next very, very important parameter is I'm going to be open up the data sheet for this one. So for this one, I'm going to be already downloaded the data sheet. Okay, I'm going to be download. I just open up my data sheet. So this is the STM32 data sheet. Okay, so this is the complete this 149 pages, which is having a data sheet for STM32 microcontroller. Okay, today we are going to be read the data sheet for specific STM32 microcontroller. Okay, so when I'm going to be open up the data sheet for every data sheet, if you just downloaded the 8051 data sheet, pick data sheet. So the first page you can able to see the features of your complete microcontroller. Okay, so what are the features for specific microcontroller? So what are the data which can I able to get it on this one? So the first specific thing is the first page, which is going to be the first page is telling all the features in brief. Okay, so you can able to get what are the details which is completely present in your data sheet. This about 149 pages. What about which is present in the 148 pages? Okay, so it is going to be tell you the complete thing on this first page. The features is it is telling you the complete details what is actually present in the microcontroller in brief manner. Okay, so that is what the first page it is going to be tell you that. Okay, in this case, these features we are going to be study those parameters. So what are the parameters which is present here? I'm just showing here in front of you. Okay, so if you just see this one, when I'm going to open the features, when I'm going to open up the data sheet, the first parameter which is telling about the what is the operating voltage, what is the power supply for your specific one. So this operating voltage, which is for 1.7 to 3.6 volt power supply, which is for specifically your core processor. Okay, so we know that we are having the microcontroller. Okay, so we are having a microcontroller inside. We are having a core processor and other peripherals has been included, right? So this concept we might be studied what is the difference between the processor and the controller. Okay, so this is my complete controller and this is my processor, and these are all my peripherals like my ADCs, my interrupts, my UART kind. This is called as in peripherals. Okay, and here the parameter is this is my core processor which can able to processing your complete thing. Okay, and this is my memory and this is my DMA and this is my ADC. This is my other peripheral UART, I2C, timer. So these are the peripherals. Okay, so your processor means only this core processor. If you are trying to be add on this peripherals, it is going to be called as a controller. So this basic concept we know about the difference between microcontroller and the microprocessor. Right. In this case, guys, the first page, what it is telling, it is completely telling about what are the features, what are the things actually present in your microcontroller. So these are the things which is present in your microcontroller. We are going to be study each and everything by completely. Okay, so first thing is it is actually telling the power supply. So what is your power supply of your core processor? If you just see this one, so dynamic efficiency, I'm going to be tell about this concept. First of all, it is having a power supply. So the range of power supply is 1.7 volt to 3.6 volt. Okay, so you can able to it can able to acceptable voltage. Okay, acceptable voltage is 1.7 volt to 3.6 power 3.6 voltage. That is the range for your complete core processor. Okay, it is range for your complete core processor. And what is the temperature range it is going to be working? Because I'm not only going to be use my microcontroller in normal room temperature, I can able to use it in industrial applications. I can able to uses in office environment, in manufacture area. So this microcontroller can able to work on with this different environment. At the time, it can able to sustain those environment, those temperature range. And what are those? Okay, so it can able to work 40 degrees Celsius to 85 degree, 40 degrees Celsius to 105, and 125 degrees Celsius up to it can able to work it. Okay, so it can able to work up to those ranges. Okay, here we have been study those concept of what is the operating voltage for power supply and what is the degree. So it is a minus 40 degree to plus 125 degree. Up to this range it can able to work. Okay, so this is the first thing called as a we have been studied about the what is the power supply of your core processor and what is the temperature range it can able to be works. Okay, and next parameter if you just see this one, okay, if next parameter if you just see this one, because it just range, guys, because if you are using one normal temperature, it can able to work minus 40 degree to 85 degree. So 105 degree it can able to up to this, and if sometimes it might be changes, the temperature might be changes up to 125 degree. So up to this level it can able to sustain it. So that is the level of uh, your complete processor, your thing going to be, your controller going to be can sustain. Okay, and then we are going to be study about the core processor. Okay, we are going to be study about the core processor. Inside this core processor, what core we are using it? Okay, here I told you This is your core processor, and these are the other peripherals. So we will study this concept detailedly. So I'm having my microcontroller. This is called my microcontroller chip. So I'm going to be open up this. So STM32. This is the microcontroller we are currently studying. Okay. So here I'm having my controller. Give me a minute. Okay. So here I'm having my controller. So this is my microcontroller, right? So inside this microcontroller, I'm having a processor core, memory, and other peripherals, UART, I2C, timer, ADC, TMA, timer. So kind of many peripherals has been inside this one. So in this concept, first, you need to be understood what the core process which is actually present inside this STM32 microcontroller, and then we are going to be study about each and every peripherals one by one. So first thing we are going to be study about what is the core processor which is present inside this. What is the core processor? Okay, so inside this core processor name, it is called as an ARM 32-bit Cortex. That means it is ARM Cortex. Okay, so it is having the processor name, it is called as an ARM 32-bit Cortex. Okay, so we know that it, guys. Okay, we are having the ARM processor core inside this. So it is based on this Cortex, and it can have the 32-bit processor. What it actually mean, the 32-bit process? Everything we will discuss it. First, you need to be understood the concept called as an, it is ARM car 32-bit Cortex of EM4. Okay, if you just see this concept, this Cortex, so inside this ARM, it is having the different one. So ARM full form is Advanced Risk Mission, right? So this ARM, which can able to work on the different applications. Okay, application oriented device you can able to create it, and real time application you can able to create it, and then microcontrollers. So you can able to create the microcontrollers also. Okay, it is based on M series. So we are created the microcontroller through this ARM Cortex processor. Okay, so ARM can able to, you are going to be keep it on the mind, ARM processor can able to design for different variants. You can able to create multiple applications. You can able to create the real-time softwares. You can able to create the microprocessors and all. So we have been created the microprocessor of M4 series. Here we have been created the M4 series of processor, CPU, central processing unit. That is a processor. Okay, so it is can able to work up to 32-bit processor core. Here I've been to put at the 32-bit processor. We know that what is meaning of 32, what is meaning of 8-bit processor. If it is an 8-bit processor, it can able to process the bits up to 8 bits. Okay, it can able to process up to the 8 bits. If it is a 32-bit processor, you can able to process the 32 bits for one instruction. So it's just taking like this one. You can able to process up to the 32 bits. Okay, it is very high amounts of bits you can able to process it. That is what just telling. And other than that, it is having FPQ. So CPU means it's just normally this is central processor. It's just a processor. And what it is along with CPU with FPU? CPU with FPU means this FPU which is called as an floating point unit. What is the meaning of floating point unit? So floating point unit is, so we know that what is the purpose of floating point unit, guys? Okay, and what is the purpose of processor? Processor purposes, it can able to do this arithmetic and logical unit. So mini instruction is going to be get processed. You can able to do the multiple functions, addition, subtraction, multiplication, and divisions, and modulus, and logical thinking. You can able to do the AND operation, OR operation, NOT, kind of all the logical, and rotate the operations and left shift. All the parameters is going to be happen, all has been done by your processor. It is having the ALU. The processor can be able to do this all the operations. So along that, if you are going to be add on this FPU, if you are going to be add on this FPU, it is called as a floating point unit. What is the meaning of floating point unit is, so whenever you need the precise data, okay, whenever you need the precise data, okay, so like point, if it is having 13.457. So you can't, if it is a CPU, it is sometimes it might be neglecting this decimal point. Sometimes it's just rounding off this decimal point. Okay, but if you are using a FPU, you can able to get the exact precise value. If it is a 13.457, yes, you can able to get this exact value on this FPU, floating point unit. So that's what some of them which is having this FPU, floating point unit. Okay. And along that, you are having this adaptive real-time accelerator. So what is the meaning of adaptive real-time accelerator? I'm going to be explain this concept. It is called as an ART. Okay. And what is the purpose is, it is allowing the zero wait state execution from flash memory. Okay. So you need to be discussed about the memory concepts and all of this. Okay. So what are those memories inside this? What are those memory inside this means? If you just see this when I am having a two memories. We will discuss about this concept. Before that, we will study what are those memories are. Okay. The memories which is having, one is a flash memory and another one is a SRAM memory. Okay, if you just taking any microcontrollers, you are having a two types of memory. One is called as a non-volatile memory. Okay, so you are having a defaultly you are having a two types of memory. One is called as a non-volatile memory. Another one is called as a volatile memory. Okay, another one is called as a volatile memory. Okay, one is non-volatile, another one is a volatile. If you are taking 8051, same scenario is going to be happen. One is volatile, another one is a non-volatile. Volatile of RAM memory, non-volatile of ROM memory or EEPROM memory. If you are taking a different microcontrollers, Arduino, so that is also having a two types of memory. Why these variant is actually going to be happen? Now we will look out this concept. Okay. So you just simply see this when I'm having a this is a non-volatile memory and this is a volatile memory. Okay, so this volatile memory, okay, first of all, if you are writing the code, okay, for example, you are writing the code on any IDE, because we have to write the code on this IDE, and after return that code you are trying to be upload the, this is my IDE. Okay, so this is my ID. So you have to use any ID to compiler. So after run this code, you're going to try to upload on your microcontroller. So this is your ID and this is your microcontroller. So after you have been written the code, you are trying to be upload the code on your microcontroller. So when you're trying to upload the code, what is actually going to be happen? You have been written the code on some language. That code is going to be converted from human language to ASCII code, human to ASCII code. That code is actually going to be uploaded on this non-volatile memory. Like here we are using a flash. Here I'm using a flash. Right. So first, when you're going to be try to upload the code, all the code is going to be uploaded on this non-volatile memory. Non-volatile memories are can't easily erase your data. Okay, we cannot easily erase your data. First, we are going to upload the data. If you are having a ROM, if you are having a EEPROM, so all the data is going to be tried to store on this non-volatile memory. Here we are having a flash memory, which is having a size of 512 kilobytes. So it is trying to be storing your data on this flash memory. Okay. Once, after, while at the time of processing, it need to be storing your temporary data. You need to be storing the data for temporarily. For that temporary purpose, it's just using the volatile memory. Like we are here, we are using SRAM memory for volatile memory. Okay, you can able to see this one, 512 kilobytes of flash memory and 128 kilobytes of SRAM memory. Here we are having a 128 kilobytes of SRAM memory. Okay, so this is the variation. So you can able to understand this concept. Here I'm having a processor core. Okay, and here I'm externally right to upload this code. When I'm trying to upload this code, all the data is going to be stored on this non-volatile memory because it is can't easily erase it off. It is going to be sustained it. Okay, flash is one of the memory, guys. Okay, these two are memory. Okay, these two are memory. So if you just look out it in normal data, we are having the different types of memories like primary memory and secondary memory. So we are having a RAM and ROM. RAM is volatile, ROM is non-volatile. In RAM, we are having SRAM and DRAM. ROM, PROM, EPROM, and flash is also comes under that. So we are having a different types in it. So volatile means so it is easily erase it off. Once we just power off your systems or microcontrollers, your data is easily going to be erased off. Even you just power off your microcontroller, it is still sustained on this flash memory. Okay, that is the difference between volatile and non-volatile memory. Okay, here, if you just see the difference, what is the memory is just having? 512 kilobytes of flash. This one is 128 kilobytes of RAM memory. So definitely you just look out for 8051 and Arduino kind of ESP30. Every microcontroller you go and check what are the difference. What is the non-volatile memory has been present? What is the volatile memory has been present? You're going to be check it out the value. Okay. Yes. That is comes under the memory. That's cool. Here we have been left out at this point called as an ART. That is adaptive real time accelerator. Okay, so what is the meaning of adaptive real-time accelerator is that is called as an ART. Okay, so it is telling like zero wait state execution from flash memory. So what I told you already, first, when you're trying to upload your code from any ID or compiler, so the data has been stored like it has been converted as a 0101 kind of thing. Because machines can able to understand only the zeros and ones. Your code, first of all, it is trying to be uploaded on this non-volatile memory, like flash memory. Okay, so what this processor is actually going to be do is, for example, this is your processor. Okay, what this processor is actually going to be do is, okay, it is trying to be fetch the data from this one. Okay, so if you just see this concept on here, because in this beginning, your compiler, your IDEs upload all the codes on your non-volatile memory. So when the processor need to be processed, where it taking the data? It's from non-volatile memory. So your data has been taken through this non-volatile memory. Okay. So in the beginning, all the codes has been uploaded on this flash memory. So the processor, which is trying to fetch the data from this flash memory and started to process on this processor code. So this processor, which is having the FPU along that. So this FPU, which is going to be helpful for giving the precise value like this. Okay. And here you are telling about the ART. What is the meaning of ART? It is called as a zero wait state execution from the flash memory. Here, what is meant by ART is, so we need to be know how much amount of data it is getting from this memory and to process. If you just see this when it can able to process 125 thrice to millions of datas. So it is trying to for 1 megahertz. Okay, it is considered as an 1 megahertz. Okay, so it is trying to be get the millions of data for 1 megahertz try to fetch from the flash memory. How much amount of data is trying to be fetched, guys? Thrice tones. So it is about the 125 millions of thrice tones of instructions. Okay, millions of thrice tones instruction. It is try to be fetch the data from here. Okay, if it is trying to do like this, what will be happens here? If it is trying to be fetch the data of amount of instruction, it is trying to be fetched here. So The instructions has been fetched from 32 bits of instruction only get processed. Why? Because it is a 32-bit processor. Here I'm right? So here it is having a 32-bit instruction process. Even it can able to process 125 million instruction per megahertz. It is a 32-bit processor. It can able to process up to 32 and 32 bits of processor. And if you just study about this ART on here, what is ART is trying to be tell is, if you're trying to be fetch the data, your data has been taken like 32 and 32 bits of data. 32 bits of data is only going to be processed. Okay. So, but what is actually going to be meant here it is the difference. Okay, the first 32 bit of data has been taken and processed, and the next 32 bit of data is going to be taken and processed. So the difference between, so the first data and second data, so there is no wait state execution. That is a zero wait state execution. What is zero wait state execution? It is not going to be wait to be fetching the data from the flash memory. So it is millions, it is going to be fetching the data very fast and doing the all the instruction going to be processed very soon. That is a zero state wait execution. And frequency up to 100 megahertz. So how much frequency it can able to maximize it? It can able to work up to with the range of 100, with the range of 100 megahertz, which is having a range of 100 megahertz. Okay, so we will see that how this 100 megahertz as was K. Okay, so that's cool, clear, and you can able to do the DSP instructions also. It is also worked on this DSP. Okay, and then we already studied about this memories, and now we are going to be study about this clocks and reset and power supply management. So the zero state wait execution. And some people have been asked the questions and yes, ma'am. So while we going to be write a code, generally you can able to understand this concept. Simple guys. When you are going to be upload this code, it just in the beginning, it is trying to be upload all the code on this flash memory. While at the time of processing, if you have been, it just processing up to 32 bits of processing, right? So it just processing the 32 bits and 32 bits of data is going to be get processing here. So this time it just processing 32 bits of processing. While at that processing, your data inside you are having the multiple data registers. If you are using a UART, if you are processing ADC, if you are processing anything, it is having some registers. That registers, that data is going to be temporarily storing this SRAM memory. Okay, the temporary usage only this volatile memory of SRAM memory going to be used on here. Okay, zero time execution is, this is the 32-bit, it processing the 32-bit, and this is 32-bit. So if the 32-bit has been processed, it is trying to fetch the another 32-bit. So it is trying to be fetch kind of lot of 32 bits as going to be processed. So when it is processed this 32-bit, it is trying to, it is not going to be wait for another going to be fetch. So it is immediately going to be do. So zero time execution is that's the meaning. It's not going to be waited for anything else. Okay, now we are going to be discuss about the clock reset and power supply management. So what it's actually mean it? So here we are having this when called as, and here I told you that. So what is the range of the power supply for core processor? So the core processor power supply can able to work with this range of 1.7 to 3.6 volt. Okay. So 1.7 to 3.6 is the operating voltage. Operating voltage means it can able to work within this range. And okay. And here we are having some other parameters called as in POR, PDR, PVT, BOR. So what are those names? So we have been completed up to this memory. Now we are going to be study about those when. So clock. And before that, we are going to be study about this concept. Okay. So this POR, which means it is called as in power on reset. What this power on reset? You are having a microcontroller board on your hand. I'm having my microcontroller board on my hand. When I'm connecting my power supply, okay, when I'm trying to give the power supply through this USB. So your complete peripherals inside, you are having the registers, everything will be there. So when you're going to be power on this, everything is going to be get resetted. Okay. When the microcontroller get powered on, everything which comes to the reset condition, that is called as a power on reset. POR means when you're giving a power to your microcontroller get power, reset it. Okay, so we are having some reset values for every microcontroller's registers. For example, accumulator is one of the register. It is having some reset value of 0000. So when I'm trying to power on my microcontroller, automatically it get reset. It come to this reset value. And then power down reset. What is power down reset is when your microcontroller which is go below this range. Your range is maximum 3.6 volt. Okay. If it is go below this range, it is automatically power resetted. So when it is go to this, sometimes the voltage drop might be happens. If it is reducing the voltage up to 2.8 volt, automatically your microcontrollers get reset your microcontroller. Okay, that is called as a power down reset. And this one is called as a power voltage detector. What is power voltage detector is? It's just indicating if the voltage is getting down below this range, you will get some notification. Okay, you will get some notification like your power is getting down this below this range. Okay, that is power voltage detector. And the brown out reset. Brown out reset is some drip going to be happened in your voltage, some voltage fluctuations which is going to be happens in your voltage. Okay, this time it is automatically get reset to avoiding some damages which is going to be happens on your microcontroller. So you might be thinking, we always thinking like if you are giving some heavy voltage, if it is 3.6 voltage, if I am trying to give 10 voltage, then only my microcontroller will get damage or burst. Not exactly. It just having some operating voltage because your core processor, this is the operating voltage for your core processor. So the range is this one. If it is below, if you just go down, if you are giving some heavy voltage, then also it is actually get damage. Okay, but if you are trying to give less voltage below this range, then also it will be get damage. So here we are having, it will be power on. So whenever it is actually get resetted, so whenever we just giving a new power, it will be reset. Whenever it is power down with whenever it just reducing, whenever the range is down like 3.6 or 2, it just downing reducing this range, then it is reset and it just giving the voltage detector. So just giving the notification and the power down. So whenever the voltage is just some trips or any fluctuations is going to be happen in your voltage, this time it is going to be a reset your microcontroller. Okay, so these are comes under your voltage and the problems which is going to be happens. And now we are going to be study about the clock frequency. Okay, so what clock frequency? So here, if you just see this when, here I'm having a crystal oscillator. So this is called as an oscillator, crystal oscillator. So through this oscillator, it producing some clock. Okay, through this crystal oscillator, it can producing some clock. So we are having a external clock also, guys. Okay, I'm going to be tell you this concept. So I'm having a clocks inside this one. Okay, I'm having a clocks inside this one. So this is going to be called as an clock. Clock going to be provided. Okay, but what is the range of this clock can able to provide it? Here they have been mentioned. This crystal can able to produce this range of 4 to 26 megahertz. What is those range? It can able to produce with this range of 4 to 26 megahertz. It can able to produce those range. Yeah. So this is the range for my microcontroller can able to produce it. So I can now able to hear. So this is my clock, and the range for my microcontroller can able to produce with this. This is my range, 4 to 26 megahertz. So this is the range of my clock can able to produce it. Okay. And then, yeah, so this is the clock can able to produce it. And if you just see this one, here the special thing which is present in your microcontroller of STM32, inside this chip, you might be thinking like, yeah, we know this crystal oscillator can able to only producing some clocks in it. Yes, but inside this chip also some RC oscillator, some trimmed oscillator is also present here. Okay, that can able to provide up to 16 megahertz. Okay, that can able to provide up to 16 megahertz. It is factory trimmed RC, we call it as. Okay, so internal purpose we are going to be use it like processor work, so other things we are going to be use it. And we are having a 32 kilohertz of oscillator. Okay, so this 32 kilohertz of oscillator, it is external, which is taking from the which is taking this crystal oscillator. And another thing is internal 32 kilohertz of RC with calibration. So internally, some oscillators there. So we have to study this detailedly. You can able to understand this concept. So I'm having a 4 types of clocks is actually presented here. First of all, external crystal. External crystal is which is using RTC purpose we are going to be using. It is completely low clocks. It is producing some low clocks because it is taking only the 32 kilohertz. Okay, it is used for this RTC purpose. And wait a minute, guys. So other than that, we are having an internal 32 kilohertz RC calibration. Same time, inside this core processors also, we are having some oscillator, an RC trimmed oscillator, which can able to use for internal purpose. Okay. So first thing is 2 types is there, internal RTC. Okay, so this internal RTC, which is going to be helpful for backups and watchdog type. Okay, so whenever some malfunction which is going to be happen, it helps to be reset your microcontroller. Okay, so we need to be understood all those concepts, guys. One by one, we are going to be studied. Okay, if you just study one by one, you can able to understand this. We are having a, it is simply keep it on the mind. This is one of the oscillator, and internally, internal of this chip, we are having oscillator. We are having a oscillator. Okay, so this is called as an internal oscillator. So this one is called as an internal, or not exactly we use the term called as an oscillator. We are going to be internal RC trimmed oscillator. So this is internal oscillator. Okay, and same time it is called as an external clock providing oscillator. It is an external clock providing oscillator. So this internal, external clock providing oscillator can able to produce with this range of 4 to 26 megahertz. So internal clock can able to produce with this range of 16 megahertz. Okay, 16 megahertz. Okay, here we are having some range. Okay, this ISE. So we are call it as a 2 variants in it. ISE means high speed clock. Okay, this external clock, this external speed clock, this is called as external speed clock, which can produce up to this 4 to 26 megahertz, which can used for outside of the microcontroller for high speed external oscillator. If you are configuring UART, I2C, SPI, these are required some high speed clocks. That time we can use this IHSE. Okay, whenever we need to be work on inside this microcontroller, it just using this HSI, high speed internal. Okay, we are having a two parameter. One is called as an HSC and HSI. Whenever you require this high amount of speed of clock, you require it, high speed of clock you require it, you just go to use this HSC. It is going to be called as the term called as an HSC, high speed external. This is going to be called as an HSI, high speed internal. Okay, so it is going to be used for this peripheral is going to be transfer, memory data going to be transferred, just going to be used. And we are along that we are having some data called as an external crystal and internal RC oscillator. It is a low speed clock. It is going to be called as an LSE, and it is going to be called as an LSI. Okay, same the low speed clock and low speed external. So here we are having another parameter LSC, and here we are having a LSI, low speed internal and low speed external. Okay, low speed internal. Okay, this low speeds and all, it is going to be used for like a RTC, backup datas, and which is going to be used in the watchdog timers. And this high speeds and all is going to be used for the multiple high speed data communications. Because if you just look out it for sending the data through I2C, UART, and these are memory data, these are required a high speed clock. That time your microcontroller can using this high speed clock oscillator, crystal oscillator. Whenever it is a simple works like RTC, watchdog timer is going to be required clock. This time it's just using a low speed clock. In this high speed and low speed, we are having a two variant. It is called as an high speed external and low speed external, high speed internal and low speed internal. Okay, so depends on this work, it is actually going to be using your clocks. Okay, and then we are going to be discuss about this power consumption. Okay, so what is power consumption? So the power consumption is simply your microcontroller can able to get how much current, how much frequency it is actually going to be taking. The main thing is how much current is actually taking in different variant. Okay, yes, we are having a different variant called runtime, stop time, and standby time. Okay, so for first one is runtime. What is mean by runtime is your complete processor is uh, working very stressful. Okay, so it is your processor is working heavily. At the time, how much current is actually taking? It is 100 microampere of current is actually taking. Okay, what does mean by stop? Which is stop, but it's not exactly the stop mode, which is called as a flash and stop mode, fast wake up time. That means your flash is actually storing some data. It's just having some data. Okay, it just easily wake up. That current is actually taking 65 microamp. And another stop mode, it is called as, it is flash and deep sleep mode. The time there is no data also in your flash memory. It just simply deep sleep mode. It is taking only the 9 microamp. And the standby mode is, it's completely slept. Okay, at the time, just taking only the minute amount of current only, just taking. Okay, 1.8 microamp. And VBAT means even your complete microcontroller gets powered off. Okay. So even your microcontroller is completely gets powered off. Externally, your battery, the VBAT is running. Why? Because it's just giving the voltage for your RTC. So here you just see this one. Here I'm having RTC. This is called as a real-time clock. Okay, real time clock means you can able to get the real time data, date, time. You can get the real date and time. How it is actually happening, even though I'm power offing, even though I'm shut down my laptop, it's still updating. How it is updating? Because in backward, the RTC is running. So if RTC is continuously going to be run, some battery, some voltage is continuously we need to be give it. So here we use this name called as a VBAT. The VBAT is called as an This battery voltage is specifically designed for giving voltage to your RTC. So if you're taking your laptop, yes, some VBAT is continuously running for giving some power supply to this RTC. So if you are taking this STM32, yes, it is supporting this RTC. Okay, even your power off, so it is continuously going to be get runs. So what is the current is actually going to be taking? It is 1 microamp of current. This is that's the temperature. So when your processor is hectic work, so it's just taking 100 microamp, and stop means it is not completely stop. In backward, so the flash memory is working, it is storing some data. That is called as in stop mode, but fast wake up mode. It's just taking about the current of 65 microamp maximum. So the typical range is 42 microamp. So stop means it is your flash is also when to sleep mode. That is 9 microamp it is going to be taking. So it is completely powered off. Only your RTC is going to be running backside. That time it's just taking 1.8 microamp. Your complete thing is powered off. How much power, how much voltage which is taking by your RTC is VBAT of 1 microamp. The temperature range is this one. Okay. I hope you got clear this point. And next, we are going to be study about the point is called as an ADC. Okay, so we are going to be study about this point called as an ADC. So what is ADC? It is having a analog to digital converter. It is the analog to digital converter. So because a microcontroller can sometimes it just taking some analog data. Analog data means it's simple. What are the data we call it as an analog data as when your data is continuous with the time. Okay, it can't be discrete. So it is continue when based on if you are taking the voltage or current or whatever the parameter is taking. When that is continuous with time, at every instant of time you are getting the data, it is called as an analog. If it is an analog, you can't able to get the precise value. We need to be converted as in some digital value. Yeah, because your microcontroller can able to understand only the binary codes, digitals. This time I need to convert it from analog to digital. For that, I'm using this module called as an ADC, analog to digital converter. So it's just like one translator. This is one of the module. How many module which is present inside this microcontroller? Only one module inside this microcontroller. We are having only one module. So only one ADC module inside this. I'm just writing here. So one ADC module which is present inside this. Okay. And here they have been mentioned like 12-bit ADC. What is the meaning of this 12-bit ADC? 12-bit ADC is you can able to get the resolution of this value. If you're ADC, you are going to be converting the data from analog to digital conversion. Okay. I'm getting some sort of data here. I need to convert it from analog to digital means I need to be resolute the value. That means if you are having a 12-bit ADC, you need to be calculate 2 to the power of 12. It is producing some value called as 4946. Okay, you are going to be implement your analog to digital value. If you are getting some random value, you are trying to be optimize to this range. Okay, if you are getting some value, I'm just optimizing like some values you have been getting. Okay, the good example we will see this one. So you have been taking one sensor called as in soil moisture sensor. Okay, you are taking one soil moisture sensor. The soil moisture sensor, I'm using one module. Inside this module, it is having ADC. Okay, what is this ADC is actually going to be do? Your microcontroller going to be convert this one. So you are having some sensor and this ADC module which present in your microcontroller, not this one. You are collecting this data. Collected data is going to be given to your this analog data, just only collecting your analog data. So this analog data is going to be given in your microcontroller. Whatever microcontroller, Arduino, STM32, any microcontroller. So it is having a one module called as an ADC. What this actually going to be do is trying to be converting your data. Okay. For example, you need to be converting the data. So if your soil moisture level, you need to be calculating the data is called whether soil level is dry or wet or good moisture or need to water. There is three parameters in it only. Okay. Here, first of all, it is dry. How the values are going to be given? The values has been given like very minute values is going to be given like this. Not in good range. So it is 0 volt to 5 volt. You need to be keep it on the mind. All the data is going to be considered as an voltage here, right? Even you are getting some different voltage, soil moisture level or any gas sensor, anything you are going to be get it. All the value is going to be considered as an between this voltage range, 0 to 5 volt range. Here, the voltage range is very minute, 1.1 volt. This 1.1 volt, this microcontroller can't able to understand this. It can only know this zeros and ones. We need to translate this. For that, we are introducing this resolution. Inside that, we are going to be using ASCII. This need to be converted. This resolution means I'm having the resolution value of 12 bit. 12-bit resolution means what is the 2 to the power of 12? It is 4096. If you're taking the value from 0, it producing from 0 to 4095. Okay. If it is a 1.1, okay, because the maximum range is 0 to 5 volt. It just simply consider 0 to 5 volt matches with 0 to 4095. And it's just trying to mapping your value. What is the value of 1.1 volt? Simply just taking the value called as 100. Okay, trying to match this value because only those range can able to understand your microcontroller. This 1 volt, this 5 volt and all can't able to understand this value. Okay, so this time I'm simply converting this values into the binary value. Okay, trying to be mapping your data. Okay, if it is a 5 volt means it's simply taking a 0.5. So I understood this concept. What I'm going to be doing is simply differentiate, simply splitting this range. If my value, if the microcontrollers is given the value to 0 to 1000, my soil is too dry. Okay, if the microcontroller can give the value 0, 1000 to 2000, my soil is just wet. Okay, and 2000 to 3000, it is moisture. It is having some moisture. And 3000 to maximum range 4095, it is good moisture, no need water. So I just simply implemented this code on my this logic on my code, simply recognizing it. Because of my microcontroller can't understand this voltage value, simply using this resolution value, simply splitting this data and implemented this on my code. This is called as a resolution. Okay, I hope you got clear, super clear on this point. So up to, so it just having this 12-bit ADs of 4096 and 0.14 mega samples. So you can able to get the more number of samples. Okay, you can able to get the more number of samples. Okay. And this ADC converter up to 16 channels. So it is having only one ADC. I already told you it is having only one ADC, but it is having a 16 channel. Yes, thank you, Mukesh. So update, so people have been posted, got clear. So thank you for all the people, guys. Okay, so it is having the 16 channels in it. We can able to use that through that one, and you can able to collect the data. If you're using the multiple sensors like gas, kind of many sensors you're using, you can use the different channels to be getting the data. Okay, okay. So yes, guys, so we have been discussing and yes, so I'm having a ADC. We have been completed up to the point called as an ADC. So now the general purpose of DMA. So the concept we are going to be discussed called as a DMA concept. The full form of this DMA, it is called as a direct memory access. So what is the purpose of this direct memory access is? So we are having a DMA, right? So we are going to be discuss about this called as a DMA. What is those purpose of DMA is? It is not going to be use your processor. Okay, it is not going to be using your processor. So whenever you are having a DMA, it is direct, the name itself, it is telling the concept called as a direct memory access. Direct memory access means you, it is not going to be interrupt, it is not going to be using a processor. Your data is going to be transferred from one microcontroller to another microcontroller directly. From memory to memory, it is going to be transferred. Okay, it's not going to be using your processor. And then it is having a 16 streams of DMA. What the 16 streams? So you can able to get the 16 stream means so 16 port. Okay, you can able to getting the data, and it is the FIFO method, first and last out. Because whenever you are having the multiple data, you're trying to be transfer from one microcontroller to another microcontroller, burst thing going to be happen, trying to be collapse. So it is going to be a first in first out. Okay, which one has been comes first? It is going to be comes out. Okay, which one has been comes first? It is going to be comes out. So this is the methodology it is going to be do. Burst mode is it can able to done by bytes transfer also going to be done. Okay, most probably we might be heard about bits by bits transfer. It can able to done by the bytes of data is also going to be transferred. Okay, are you clear, guys? Now we are going to be discuss about the next concept called as an timer. Okay, in this first page alone, I am explaining about all the peripherals. Okay, in upcoming inside this masterminds and all, you are going to be deeply study about every concept. Okay, and here we are how many timers we are having. So we are having the 11 timers. Next peripheral, we are studying about the concept called as 11 timers. We are having 11 timers. So what is the purpose of this 11 timers? Okay, we are having a concept. Next concept, it is called as a timer. So sorry for this one. So next concept we are having called as in timers. So this timer, we are going to be detailly discuss about this. Always this timer which is going to be used for the PWM, that is pulse width modulations, and we are going to be used for delay generations and high precision time measurements. We know that when it is clock going to be provided by oscillators. We need to be count that clock, the tick time, so everything we are going to be counted. So who's going to be do this timers? So this timer which is going to be helpful for counting all the datas. So what bit of data it is having? It is 11 bit. So the 11 timers it is having. Okay, it is having the 11 timer, 11 different timers we are having. So what are those? First of all, we are having a up to 16-bit timer. We are having a 16-bit timer and two 32-bit timer. Okay, 16-bit timer and two 32-bit timer, which is working with a range of 100 megahertz. Charlotte, I already told you that your external clock is working 4 to 26 megahertz and internal clock is 16 megahertz. How does we get 100 megahertz here is we are using one thing called as a PLL, that is called as a phase lock loop. We are using the parameters called as a PLL, that is called as a phase lock loop. So whatever the data, whatever the frequency you are getting, it's just simply doing multiply and dividing your data. What is actually doing? Multiply and divide. So if you are getting the 16 megahertz, it just multiply with the 16 by 2 and you will get the 2, and again it just multiply with 100 and you will get the value called as in 200, and again you just multiply with 2, you will get the value called as in 100 megahertz. So I'm just simply do this calculation. This is how it's just calculating. You might be thinking you're just calculating with some random number. No, you are already given I need 100 megahertz. Okay, you have been given the data called as in 100 megahertz. I required it. Okay, this is the final data I required it. But depends on that maximum range. The specific ID you are going to be using. Okay, it is going to be done this calculation. The PLL is specifically for that one. So depends on that value you have been given. You are only going to be giving 16 megahertz. You have been very clear on this point. I only giving the 16 megahertz. Okay, my maximum value is 100 megahertz. Okay, for that range you need to be multiply and divide the value. For to get that range, I need to multiply and dividing the value. Okay. Okay. So for that range, I need to be multiply and divide the value. Okay. Yes. So first of all, it just done the divided by 2. You will get the value called as in 2. Again, it just trying to multiply with 100. And then that 200 has been divided by 2. I will get the exact one. For in this case, you are trying to give the 16 megahertz. Okay. You are trying to give the 16 megahertz. The value that is the constant internal value. The final maximum range you required it for 80 megahertz. You already given you required for 80 megahertz. For to get this 80 megahertz, it is trying to multiply and divide the value. Okay, so if I want to get the value called as an 80, depends on that it is trying to using this parameter, dividing and multiply parameter it is going to be using. That is called as a PLL, phase lock loop. You are giving some input voltage, input frequency. You have been giving, trying to give. So you required some output frequency. This is my maximum range. Depends on that. It is trying to use some parameters 200 and divided 2. So you have been using 2 divided with 2, multiplied with 200 and divided with 2 again to get this value. If you want this value called as an 80 megahertz, it need using some values to be get this value. Okay, that is the actual purpose called as a phase lock loop. And along that, up to 4 that is called as an input captures and output capture and PW and pulse counter. So along that we are having a 2 watchdog timers and we are having a stick timers also. We are having the multiple types of timer. Okay, simply I'm going to be tell you this concept. Here, normally this timer which is going to be used for phase pulse width modulation. Whenever we need the pulse width modulation, we need to be calculating delay going to be generation, every high precision time measurements, everything is going to be done by here. And input capture. Okay, measuring the pulse width. So pulse width and frequency time intervals, it is called as an input capture. Output capture means generate the precise time intervals. Pulse width modulation means you want to be blink one LED. Okay, I want to blink one LED. If 0 means off, 5 means on. You want to be change the pulse. You want to be changing the brightness of this pulse. That time you can use this pulse width modulation. Yes, Abchit, it's just using this frequency range. I mean crystal oscillator range for the system there. Okay. Crystal is just taking from 4 to 25 megahertz and internally some RC circuit is there. So we already taken one specific class, how this actually creating. It has required some RC circuit. We need some oscillator. We need some oscillator. We need to connect one RC circuit or LC circuit to providing some clock. When you're going to be give some voltage, some piezoelectric get disturbed. So all thing has been discussed in previous class. And or counter. Pulse counter is also going to be. So all the counting purpose, your pulse counter, time counter is going to be done by your timers. Now, what is the speciality of this watchdog timer and the stick timer? First, this watchdog timer, it is whenever the malfunction is happening. Whenever your microcontroller going to be do some malfunctions, that time it is going to be performing. Okay, so like it is trying to reset your microcontroller. What is actually going to be do? It's just trying to reset your microcontroller. What is the meaning of SysTick timer? SysTick timer is, it is 24-bit timer. It is present inside your microcontroller chip, processor chip. Inside your processor chip, it is having this one, guys. Okay, inside this processor chip, we are having a SysTick timer. It is specifically, we call it as a special timer. Why it is special timer? Because only need to be calculating for processor producing some clock. So that clock, it is counting that clock. We told you that we are having some special RC circuit. This is that RC circuit. It providing the 16 megahertz. If we need to be counted one, so we are going to be using the SysTick timer. It is having some SysTick timer. And then we are having a debugging mode. So what is the meaning of this debugging mode? Serial wide debug or JTAG is applicable. Whenever we are trying to be uploading the code, we are having a two parameters. Okay, it is a stealing, it is a serial wide debug. Serial wide debug. You can able to see this one. So this is very, very important parameter. Why it is very, very important parameter is this is how through this one you are going to be debugging your code. Okay, through this ST link, it's just collecting the data. The flow will be, we are going to be having some USB. We are having some USB and we are having this ST link and we are having some serial wide debug. Okay, so through this ST link, so we are USB, this is USB, it just connected with your USB and this ST link is going to be enabled. So through that only it is sending your data to your serial wide debug. So this serial wide debug, which is specifically helpful for debugging your complete parameter, your codes, everything is going to be debugged through the serial wide debug. And along that, we are having embedded trace macro cell. What is the meaning of embedded trace macro cell? And ITM parameters is also we are having. So it is helps to capture all the instructions. So along that, we are having a ETM, right? So here we can also use the JTAG, guys, but here we are using a serial wide debug. The flow is, we are just having through USB, you are collecting the data. Through ST link, all the data is going to be sent it. And finally, you will get the serial wide debug. And we are having the parameter called as an ETM, called as an embedded trace macro cell. What is the purpose of embedded trace macro cell is? It is capture all the instruction. Instruction is your data. Okay, all the data is going to be get captured and it is going to be get helpful for process. In ITM, ITM is also one of the parameter we are going to be used it for to debugging the code because in your STM32, your console, because you are opening up any compiler, you are having some console window. In STM32 Cube ID, the console window is not going to be exactly going to be open. You need to be open up the ITM. Then only you can get the data through this ITM. How we are getting the data through this ETM in hardware, in software, we are having a ITM to get the data. Okay. So in depth, while we are going to be studying about this STM32, you will get this concept. Okay. Got clear up to this point? And then we are going to be discuss about the point called as in GPIO pins, guys. So what is the purpose of this GPIO pins? GPIO means how many GPIO pins I'm having. How many GPIO pins I'm having. So GPIO pin modes, it is we know that how many pins we are having in this GPIO pins. We are having a alternative input, output, analog, and alternate. We can use it because if you are having a GPIO pins on your board, we are having the multiple GPIO pins, right? We are having a multiple GPIO pins like that. So what is the purpose of each and every GPIO pins inside that? It is externally only going to be presented like this. What is the purpose of each and every GPIO pins? GPIO means the full form is general purpose input and output. So because I'm having chip, even though you are having the whatever the chip, Without this GPIO pin, you can't use it for any purpose because this GPIO pin is like your cell phone. Okay, this is you. This is your friend. If you two want to communicate, this you are definitely going to be use any mobile phone or anything you're going to be use it for to communicate. That mode is called as a GPIO. Okay, so this GPIO can able to transmit the data from microcontroller to another microcontroller, or you can able to send or receive. So this can able to communicating by each other only with the help of this GPIO. Other than that, we can use it for analog purpose, and we can use it for the alternate multiple functions also able done by this GPIO pins. Are you clear up to this point, guys? Yeah, so next one is for we are going to be study about the concept called as an so GPIO it is that purpose, and we are having the different GPIO capability also we are going to be discussing. What are those is it is having 81 input and output pins which can have the interrupt capability. Interrupt capability means you can able to interrupt. You can also use some in what it is we will discuss in this one coming session. 81 your output pins, you can use it as an interrupt capability. And another 78 GPIO pins, it is very fast input and output. So you are having some sort of GPIO pins like 100. In that, 81 is having the capability of you can configure the interrupt also there. Interrupt means so while some function is happening, you can trying to interrupt with external event. Okay, that is 81 pins is going to be 2. And another 78 for fast pins. So if you are having 78 is for fast communication. That means it can able to work on only this 78 pins can able to work on 700 megahertz. Fast speed of data communication is going to be happen. And another 77 pin is for 5-volt tolerant pins. Okay, 5-volt tolerant pin means 5-volt tolerant pin means I'm going to be tell you that it is 77 pins, right? So 77 5-volt tolerant. Tolerant means here we are inside that we are having some voltage regulator. What is the purpose of this voltage regulator? Regulator means regulating some voltage. Your core processor having some voltage range of what is the operating voltage range of your core processor? 1.8 to 3.3. If I am giving above those range, it might be get burst out. Okay, so this 77 pins which is having the tolerate range. So the tolerate input output pin means it is converting your 5 volt to somewhat 3.3 voltage. Because it shouldn't affect your core processor. Your core processor can able to work on this 5 volt. Okay, so these pins which can able to tolerating this 5 volt to 3.3 volt. Okay, and finally we are having the very important parameter is called as an communication protocol. Because up to this GPIO pins can send and receiving the data. And why we need to specifically go for GPIO pins? Here I'm going to be show my GPIO. I mean communication protocols, guys. Okay, here I'm going to be show my communication protocols things. First of all, what are the communication protocols I'm having? I'm having I2C, UART, SPI, I2S, and USB. First, I'm going to be written this concept. And then what is the purpose of each and everything? I'm having UART, I'm having a UART exactly here, and I'm having a I2C, I'm having I2S, I'm having a SPI and USB OTG. USB of 2.0, okay, USB of 2.0. I can't able to give it inside this one, so no space inside this, so that's why I'm just giving above this one. So I'm just simply so all as inside your microcontroller only. Okay, there is no space. I'm just showing it. Before you need to be understood of each and everything. What is communication protocol? Communication protocol is just for communicating with the external devices. If you are having one device, if I'm having this device, if these two devices communicating, simply sending and receiving the data is called as a communication. Protocol means whenever some rules, set of rules and regulations which is trying to be comes, these two devices should communicating with this distance. These two devices should communicating with this speed. These two devices which can use only these pins. Whenever some rules which is dominating this devices, it is called as a protocol. It is having set of rules. Okay, so it should be communicating with this range, with the speed, with this. It requires some clock, with this having some when. All has been comes under the protocol. If you just look out each and every protocol, use are going to be differ in some variation. SPI is going to be different. I2C is different. I2S is different. USB is different. These all comes under the protocol. So for each and every protocol, we are going to be deeply discuss about inside this our mastermind live session. Okay. So you just simply look out how many protocols is there. We are having a 3 I2C and 3 USART and 5 SPI and 5 I2S protocol. We can use it for the multiple applications, and SDIO is also there, and ST other things we can use it, and then USB OTG. Normal, you're just giving a power supply concept, right? Through that, you can able to send the data also. Okay, and finally, no, we are going to discuss about it just having a CRC. It is the full form of cyclic redundancy check. So it is a very important error detection. So whether all the data is coming in proper manners or not. And then you are having a 96 unique ID. So how we are every device is having some MAC address, kind of every specific address. If you're taking any device, any sensor, anything else, it has having some unique address. Right. So that's how your microcontroller is having some unique ID, 92-bit unique ID. And then you're having RTC. So you're having a hardware calculator. So how it is, it's look like this. So you can able to configure in your microcontroller like what's the time now? We are having in the time of uh, I'm having in the time of 11, 12, 5. And what's the seconds? We can also get the seconds also. 35 seconds. And what's the date today? Date of 11, 10, 25. Right. So this data also you can get through this process. Because why? Because we are having a RTC inside that. So for that, we can able to get the current date and time. It is also applicable here. And finally, how we have been designed the chip. Because not only we are having this STM, inside this STM32, we are having the mini series. This is the exact series of STM32 F411RE. Okay, F411, STM32 F411R. Likewise, we are having STM32 F4B, C, CC kind of thing. How the variation has been came here it is, it comes from the variation of this one. STM32F4 XC, STM32F4 XE. So what is the difference? Why we comes this variation? Varnat Gupta, which is having the time of 12/7. Okay. Uttar Pradesh. So here we are having a two series of port. It just subfamilies. This is family, subfamilies. CC, RC, VC. In XC, we are using CE, RE, V. We are using a specific board of RE. Okay, and inside that many packages are there, like WLC. Okay, and this is a quad flat package. And it is ultra quad flat package, ultra fine quad flat package. If you are design the chip, we can able to design the multiple variant, what the variant we exactly wanted. That is the thing. So guys, can you able to believe this? We have completely studied about this feature of what are those GPIOs is present here, right? And we are discuss about the what are the package. So these are the different packages name. So finally, I told you the two variants. So some people have been asked this question also. What are the two variants? Okay, two variants of XE and XE. Okay, the example. So STM32 XE is having a 256 kilobytes and it is having a this one. Okay, so for I'm just showing you this thing. So when you're going to be study this concept, you can understand. We have been successfully completed this feature part, guys. And in this, I'm going to be telling you everything easily because when you get the knowledge, when you study this feature part, you can able to easily understood this concept. So in this introduction part, they have been given what have we studied up to yet. So what are the series, XC and XC variant, right? And if you just see the description, yes, up to it, what have we studied? So it is having a 32-bit processor. It is a RISC-based architecture, guys. Keep it on the mind. Two types are there. One is RISC and another one is a CISC. Okay, so it is a reduced instruction set. Okay, so yes, guys, so PPT and everything is going to be comes under this membership only, guys. Okay, so we'll discuss at the end of this slide. Okay, and the Cortex M4 features, it is having FPU products, and these are the topics we have been already discussed. If you just scroll down, okay, you can able to check what are the applications with the help of this this processor, this microcontroller, where it actually going to be useful. Motor driver, application control, medical equipments, industrial application like PLC, inverters, circuit breakers, printers, scanners. And these are the applications. Okay, so these are the applications which is going to be helpful to you can utilize this. You people have been asked the question, right? What is the difference between XC and XC variant? So this is the thing. That is, if you are designing one microcontroller, it is having different series. So if we are taking XC variant, in flash memory, just only the 256 bytes. In XC variant, the flash memory is 512 bytes. In SRAM, both are same. GPIO opens, same. Timers and other communications are same. And difference in GPIO opens, what is the interrupt and what are those? So the variance we can able to different it. So operating voltage is same. Microcontroller maximum frequency is also same. And what are the packet? So if you want, the only difference is flash is here varying. So if you're just comparing with this different series, each and everything, some peripherals is going to be varies. Okay, here the variation is memory. Flash, if you want the less memory, if you are using if you only want this less memory size, so you just go with this XC variant. If you want this high memory size, you just go with this XE variant. Okay, and the package size is also you can able to differ it. That is the big difference of this one. And, and okay, so you can able to see this protocols. If you want using the different one, it is going to be vary. And in this introduction part, they have been given the general introduction about this one and memory buses concept. What is a flash and AHP1 bus? And the peripheral interface protocols they have been given. Operating voltage. What is the operating voltage and what are those applications? So we already discussed it, right? Mobile phone, mobile application, consumer applications kind of thing. And very, very important part is block diagram. Okay, so now if we just see this one, so this is the series. Okay, this is the series, guys. So if you are designing your package, the package is different. Okay, this is a low quad flat package. This is a low fine quad flat package of 100 pins. If it is 100 pins having, this is how the structure you are going to be getting that. It is also low quad flat package. It is having a 64 pins. You are going to be arranged like this. Okay, so if you are using a quad flat package, if the pin is having 100 pins, if you are having a 64 pins, this is how it has been arranged. That is the thing. And then very important thing is block diagram. What is the meaning of block diagram? You know you are having a chip on your hand. Could you able to see inside this chip? Could you able to see inside this chip what is actually inside this one? No. And how this has been connected with everything, every peripherals, it has been connected. This GPIO pin is connected with this one, with this one, with this one. No, everything we can't it. So this block diagram is specifically for, yes, no guys, no, obviously no. It is telling like complete chip. So whatever thing which is present inside this chip, it is going to be tell. Like I told you, we have been draw one structure. Like this is processor, this is flash memory, and this is some other peripheral ADC, this is UART, timer, and everything is there. If I want to see it in real time, you can able to check it on it because this is your processor. Because inside you are having memory. So this is my another memory, and this is my another memory. And DMA is there, and all the GPIO present inside this one. And if you just see this timer, USART, SPI, ADC, temperature sensor, and I2C, USART, timer, and you can able to see this backup registers, PWR, watchdog timer, and reset or brownout reset, and your RC register, phase lock loop, and the voltage regulator, the tolerant voltage is done by here, and USB OTG and buses. So whatever the things which have been studied up to yet, which is present inside your microcontroller, everything has been represented in the block diagram. I can simply study this one. And all the peripherals okay. And what about this AHP1 ABP bus? Because most probably this highlighted are this buses. So what are those purposes? If I want to communicating with this GPIO pin with this timer, if I want to communicating with this GPIO pin with DMA, GPIO pin with CPU, this bus is only one important parameter. It just helps to communicating with each other. Here I'm having one resistor and I'm having one capacitor. If I need to connect with this two thing, I need to use one jumper. So that is electrical connection. So here inside that they have been using the buses to transferring your data from one peripheral to another peripheral. That is the main motor reason of this one. Okay. Here they have been using the buses, and in this buses it is having the two variant. It is called, here I'm going to be write this concept. It is called as an AHB and another one is called as an ABP. What is the purpose of AHB means? If you want to configure the high speed buses, okay, which is going to be transferred the high 100 megahertz kind of buses, you can connect that. You just use this IHB bus. If you want to connect with this, or if the peripheral can able to work with this low speed, okay, that is 50 megahertz, you just connect with this peripheral bus, ABP. Some peripheral bus can able to work with this 100 megahertz also. Most of your peripherals has been connected with this peripheral bus. If high bus means you are going to be connected with the processor, your memories, your DMAs has been definitely connected with this AHB bus, advanced high bus. Okay. And this is what this block diagram is completely going to be tell. Okay, interconnection between the peripherals and processor. And then pin configurations and functionalities. What are those pin configuration and functionality? Because we have been completed about this functional overviews we have been completed. So this functional overview, guys, what are those we have been studied up to yet? It is telling each and every purpose. We have been studied about the what is FPU, what is ARM Cortex, what is flash memory. It is going to be telling here. And what is adaptive real time. Okay, zero wait states, wait state. And it is going to be tell about the memory production unit. So memory production unit is, it is protecting your memories. Okay, and when it is helpful for invalid memory whenever it is going to be happen, so it is avoiding those conditions. So that's what the main purpose of this memory production unit. Other than that, we are having a flash memory. Okay, so we are having a flash memory which is going to be storing your complete data, and the cycling redundancy test and the SRAM. And we have been studied about what is TMA. We have been studied about NVICs and all, which is going to be comes under year after the class. Okay, and we have been studied about the clocks and what is a power supplies, schemes. So everything we have been discussed it. Now we have been going to be study about the pinouts. Okay, pinouts is very important parameter because each pin has been connected with which peripheral. We need to be understood this concept. Okay, and this time what I'm going to be do is I need to be show you the thing. I'm using a wave. This is one of the package. Okay, and this is how inside this pack pins has been allocated. It is in the round form of pins as going to be allocated. Okay, if you're using a ultra fine quad flat package, it is having pins in the size shape. It is having in the shape. If you are using a quad flat package, which is having 64 pins, it is has been arranged like this. Here we are having a quad flat package of 100 pins. It is in this. This is how it has been arranged. Okay, and if you are using ultra ball grid arrays, it is called as in ball grid arrays. Pins has been allocated. So it's no matter, guys. You can able to design the different microcontroller. Okay, about this series. If you want to be designed based on this waffle package, it is your pins has been allocated in this manner. Your GPIO pins allocated in this manner. If you want to be using a ultra fine quad flat package, your pins has been allocated in this manner. You are going to be selected what chip you're going to be using and which variant you're going to be designing your board. Okay, for that, if you're designing the complete board, you're going to be using the complete the schematic diagram. You can take it from here. Okay, and then here, it's just the abbreviations, guys, because sometimes the pin type. So if they're mentioning yes means it is a supply pin. N means input only pin. In most of the cases, they might be mentioned like this. If we are beginner, okay, if you are beginners, sometimes we doesn't recognizing what is meant by S. It is called as a supply pin. We don't know what is I. It is a input only pin. It is called as an input output pin. FT means it is whenever they have been mentioned FT, it is called as a 5 volt of tolerant pin. If they are mentioning TC, it is called as a standard 3.3 volt pin. B means it is bootloader pin. So that's how we are going to be recognizing. That is abbreviations of each and every pins. Okay. And now we have become very important concept. The concept is, yeah, I'm going to be open up my microcontroller. Here you are seeing the different GPIO pins, right? Here you are seeing a GPIO pins of different pins. For example, I'm just writing a okay. So STM32, I'm just putting a full name. Yeah, so this is my GPIO pinouts. Okay, guys. Simply they have been given. I'm just seeing the pinout. If you just see the difference, yes. What are the pins I'm having? This is the Arduino connectors that GPIO pins are. Okay, that is Arduino connectors is also there. Okay, these are called as an Morpho. Okay, these commonly we call it as a GPIO pins, right? Commonly we are going to be called as a GPIO. But in this time, I need to know what this PC10 is going to be doing because we are having the multiple peripherals going to be performing in each and every GPIO pins. Because I need to know where this user is, what is the GPIO pins of user. I need to know, right, what is the GPIO pins of user. I need to know what is the GPIO pins of I2C, I2S, and ADC, TMA, timers. Where did I get this data? From here. If you just look out this pin now, they just only given the pin numbers. Port C8, port C9, port C10. If I want to know what is the specific configuration can able to do with this pin. If you just see this one, guys, you can understand this concept. If you're taking a PE2, okay, if you just see this one on here, PE2, definitely going to be presented here. Okay. Currently, it can't able to reach into my eyes. Okay. For another example, we just take it called as an it is external pin. So I'm just taking for example PC0. For example, yeah, PC0 is there. Okay. The pin number is 6. What is this pin number? Is guys is 6. Okay. Sorry guys, it is for 85, ADC5. I was confused. Okay, 85. You can able to configure the analog pin. This PC0 is for 38th pin. Don't confuse it. It is 38th pin. There is a different in board pins and GPIO pins. Okay, this is called as in board pins. Okay, these are called as in board pins and it is GPIO pin. The board pin is 38 and it is called as in GPIO pin. GPIO means it is general purpose input output pin. Okay, port pin of specific port 01 is and 38 is the port pin and it is a GPIO pin. And if you just see this one, PC0 can able to do only event out. Okay, and can able to do the ADC one also. You just see the example. Yes, you can also configure the ADC. At the same time, you can be able to do the event out pins. Okay, if you just see the other example, for example, I'm just taking a port A1. Okay, for example, I'm just taking a port A1. Here I'm just seeing the example of port A1. It is, yeah, here I'm having a port A1. Okay, so in this port A1, guys, the port number is 30. GPIO is A1. Okay. So what is the purpose? If I simply randomly look out this board, I can't recognizing it. What is the GPIO port A1 going to be do? I need to be referred this. What is the GPIO port A1 can able to do this? So here you need to be added for alternative functions. Here it has been telling you can able to configure the timer 2, timer 3 configure and SPI 4 configure, user 2 configure and event out configure. You can do all this function on single port A1. How did you get this data? Because of seeing this pin configuration. And also additionally, you can configure ADC1. ADC1 as separate A1 is there. You can configure this pin as well. If you are trying to configure, yes, this is also going to be work. That is called as an additional features. Okay, so this is what exactly this pin configuration as was given, guys. If you are taking PB1, if you are going to be refer this, what is the purpose of PB1? Yes, you can able to get all those data on there. Feature C1, PB1 is 24 pin number. If I simply look out my GPIO my microcontroller, I can't recognizing what is the functionality. You need to refer this. Timer, you can able to configure SPI and even out. For everything, you are going to be look out like this. Okay. And if you just scroll down, you will get the concept called as an alternative memory mapping, function mapping. Okay, alternative function mapping. So whenever, okay, whenever you are just having this one, okay, so whenever you are just having this one. So Hitanshu, did you purchase this course right now? Did you purchase the course right now or previously you have been purchased? Please give me the message. I will transfer your details to my team. So if you have been purchased the course right now, you give me your mobile number and mail ID. So I will give to my team. They will enroll all the courses for you and mention what the courses you have been purchased. Okay. If you just see this alternative mapping, guys. Okay. If you just see this, what is alternative mapping? I'm having a different pins here. Okay, I'm having a different pins here, like port A0, port A1, port A2, port A3 kind of thing. Okay. In some cases, if I want to configure only one pin, okay, if I want to configure only one pin, that means I want to configure only port A5. Okay. I need to configure only Spotify. It's fine. I simply use only this, only seeing this concept, only seeing this Spotify and refer this. If you're using multiple pins, like if you're taking a UART, guys, in UART or USART, whatever it is, for example, I'm just telling, or okay, here I'm having a good example. You can easily understood this concept. Okay. Hmm. Okay, I will take the very easy example. Okay, we are going to be taking I2C. Okay, I2C is one of the protocol. Okay, in this protocol, it is having a two pins called as an SDA pin and SCL pin. Through that, you can transfer the data. Through that, it will be producing clock. Okay, and inside in I2C, definitely you would require two pins. If you are configuring ADC, only one pin is enough. If you are configuring a timer, only one pin is enough. Configuring LED, push button, sensor, or one pin is enough. If you try to look out communication protocols, it does having a two pins, configure that. This time I'm having SD and SDL pin. So, for example, I've been used the pin called as an one is PB6, another one is a PB7 because I definitely required to use two pins to connect. So one is SCL and another one is a SDA. I've been used the two pin. Okay. And this time I need to be connected with my any microcontroller. So definitely you should map this value because it is having a different pins, different pin I'm using. You should mapping the values. Okay. That time you're going to be use this alternative function mapping. You need to be mapping the values. Okay. So that time, so I'm using this section. I'm using this pins. I'm going to be map the value of AF04. Okay. So I got clear, guys. You got clear. Just post clear on the chat box. So yes, up to 8, all the people have been got clear. Just post clear on the chat box. So I'm going to be transfer this message to my team, guys. Okay, no worries. My team will be contacting. Okay. So Vibin has got clear. So many people have been got clear. So nothing is there, guys. I'm having a two pins. Okay. If I require the two pins, I require. If we are taking I2C, I require two pin. One is called as an SDA and another one is called as an SCA, clock pin. Okay. If I require the two different pin, I need to be map it. Just keep it on. I need if I'm using a two pins, I need to be map it. Okay, that is called as an alternative function. Whenever you're using a different alternative function pins, different pins, okay, different pin whenever you're using, you should be map it. Okay, you should be map it. That is the function. Thank you, SDK. You have been posting again and again. Happy to see your message. Okay, okay, guys. And now we are going to be specifically discuss about the memory organization. Okay, we have been discuss about the thing. So whenever just keep it on the mind, different pins whenever we are using, you just need to be mapping with the alternative function mapping you're going to be doing. If you just take it, all the things we are going to be used in the program only, guys. Okay, all whatever things which I'm telling. So these are the things we are going to be configured in the program. Then you can clearly understood this concept. Okay, up to 8 we have been cleared. So now we will move to the concept called as a memory organization. Okay, we'll move to the concept called as a memory organization. And yes, if you just open up the memory organization of everything, it will be looks like this. Okay, if you open up the 8051 and everything, so the structure going to be differ, but the same scenario is going to be happen. Okay, every peripheral, every memory, everything which is having a separate memory. boundary address. Okay. So first of all, I'm having the memory address. I need to be find it out. So some lag is going to be happen, guys. So wait a minute. We'll discuss about the memory mapping. Okay. In this case, if you just look out it here, guys, I'm having the different sections of memory. Okay. Here, if you just see this, every peripheral has individual boundary address, GPIO, A, and everything which is having some individual boundary address. Okay. You will got clear up to this one. If you just see this concept, okay, if I'm just taking the for each Cortex M4, this is the internal peripheral. Your Cortex core processor is having some boundary address. Everything which is having some individual address, guys, and before that, each and everything's having some boundary address. Boundary address means bound like from this to this. Okay, so it is having a boundary, the peripheral which is having boundary address of this to this. Starting, this is the ending address. And if you're just taking some map, it is not used when it is reserved. And peripherals, it's starting from this to this. And if you're taking SRAM memory, this. Yes. If you're taking a block zero code, it is indicating flash and it this to this. Okay. If you're not understood this here, you can simply take in the data from here. Okay. So your SRAM memory can using the address, boundary address of this to this address. Okay. And this to this address, optional bytes, you can use this memory. This is extra storage. And system memory, which can use this to this memory address. And the flash memory, which can use the address between this range. And boot, other pins can use this range. Okay. All your buses can use this to this range. ABP bus can use this range. ABP 1 can use that range, ABP 2 can use that range, and AHB 1 can use this range. So this is starting and this is ending address. And AHB 2, this is starting and this is ending address. Cortex M peripheral, this is starting and this is ending address. So this is the peripherals, buses, and memories address. Okay. If you want to know each and every peripheral boundary address, you're going to be look out this. If you're taking RCC, this is the boundary address. If you are taking GPIO-H, this is the boundary address. GPIO-E, this is the boundary address. For each and every peripheral, we are having a specific boundary address. That is called as a memory organization. If you just see this concept, each and every peripheral, it is having an individual address. Okay. Okay, got clear? Yes. I hope you got clear up to this point. Okay. So we'll move back to this. So don't confuse it, guys, and don't try to memorize. Or because this memory organizations and all, you don't memorize this one. Okay. All has been default. You just simply download the data sheet and see it for every peripheral. Watchdog timer, boundary address. This timer memory, boundary address. This is just only the boundary address. From here, you need to find the what is the exact memory address of this timer. Okay, that we are going to be find it out. You're going to be take it from this address from AHP to base address. We are going to be see it at the upcoming class. Okay, when you're going to be add this value, you can get the exact address of this value. Okay, that's it. And this is called as a memory organization. In this memory organization, you're going to be find out what is the flash memory and optional size, and you can able to get the all the peripherals and data memories. You can able to get it on this one. All whatever the things which is present in your if you just see this, all the peripheral which is present inside this, all the peripheral data, all the peripheral address, you can able to get it. You're not exactly use the boundary address, guys. Okay, you need to be understood this concept. You're not going to be use the boundary address. You have to use the exact address. Okay, exact address only you're going to be used. How do you take on this one is that is you're going to be have this one on your reference manual. Okay, for example, if you're just saying one, I don't want to confuse you. Yeah. So you are having address offset. Okay. You're going to be add with the address offset with your boundary address, and you will get the individual address of that one. Because each and every bus, yeah, you're just having some address offset. Okay. And then get this one. For example, if you're just, for example, you are having some, just duplicate this and go to this memory mapping and go to this one. So here I'm having a AHP1. If I want to configure AHP1, in this AHP1, I'm specifically using a GPIO. Okay, I need to configure the GPIO. The boundary address of this one is this. Okay, and you need to be finding out what is the base address offset of this one. So you just take it the data from the reference manual. Reference manual. What is the AHB1? I'm just simply taken the data. AHB1 ENR. Yeah, here it is. What is the address offset? It is address offset of 0 cross 30. 30. Here I'm just go to this one. This is my starting address. So I'm just multiply 400 to sorry. Complete 0 to 0000, right? And you're going to be add with address offset of 0 cross 30. So what the value will get? So we'll get some 30. So like 0 cross 4002 and 0030. So this is the specific address of this GPIO. That's how you're going to be find it for every GPIO. This is the boundary address. Okay, because depends on this address offset, it is going to be varies. Okay, that is the thing. And next, we are going to be discuss about the electrical characteristics. Okay, electrical characteristics of this one. So what are these electrical characteristics? If you have to take the data from electrical characteristics of to reading from here. Okay, so you're going to take the data from here. So each and everything while you're going to be read this. So how much ADC can taking the current voltage. So you're going to be read out everything. What is meant by VDD? What is meant by BSS? So what is the maximum current is going to be taking? Everything you're going to be reading. So I'm just simply telling this one. What is the absolute maximum rating? What does mean by absolute maximum rating is if you're giving this range, it is causing some problem to your microcontroller. So supply voltage, you need to give the recommended voltage. So recommended voltage means this is the voltage range you need to be given. Voltage range is 1.7 to 3.6 is the voltage, 1.8. Okay, exactly. If you are trying to give, you just see this minimum voltage. Whenever the voltage is dropping below this minimum range, it causing a problem, right? So this is called as an absolute maximum rating, maximum to minimum rating. So 3.6 is the maximum. If you're trying to give 4 voltage, it's causing a problem into your core processor. So other than that, what is the analog supply voltage? Exact voltages you need to be give the 1.7 to 3.6. If you are try to give this voltage, it's causing a problem. What is the input and output pins? A maximum range it is. Okay, and the storage temperature is this. It is absolute maximum, but you should give the minus 40 to 85 degree. You should give. And the maximum current for each and every input output pin is taking 25 milliamps. It is a maximum. The absolute range is it is going to be differs, and temperature range. Okay, and this is the exact value. This is the exact value of clock is going to be provided 4 megahertz to 26 megahertz. Internal clock is. These are the absolute data. I mean, the recommended data. Okay, these are the recommended data which is given into your which is given into your data sheet. So these are the absolute maximum data. If you are giving above this range, it causing some problem. Okay, and then power consumption. What is the meaning of power consumption? Yes, we already discussed. Okay, we have been discussed this power consumption. Then your when your CPU processor is completely working at the range of 100 megahertz, because it's intensively working, it's just taking 85 megahertz. If it is in sleep mode, other peripherals are on, like flash is on, just taking 40 milliamps. It is in low sleep mode, it is 5 milliamps. If you are using a stop mode is completely it's get off. Your flash is also get off. That time it's just taking 128 microamps. Standby, all the peripherals on off. All the peripherals completely get off. Okay, only your RTC is get on. This time, this stop mode, your SRAM is only on, other peripherals are off. Okay, your SRAM and RTC is only on, other peripherals are off. That current only taking 120 microamp. Your standby mode is RTC is only on. Okay, that time it's just taking a 15 microamp. Standby mode is another standby mode is also there. That time the RTC is also completely off. It's just taking well a minute micro, 2 microamps is only going to be used. Okay, if your internal RTC batteries get turned off, uh, this time it is going to be clock oscillator. We are having internal clock of HSI and LSI. So internal clock is just taking a 16 megahertz, and the internal low speed clock is just taking a 32 kilohertz, and external it's just taking a 4 megahertz to 26 megahertz, and low speed external is just taking a 32.7 kilohertz. It is going to be using. And input characteristics. So all we have been already discussed. That's what I'm just simply telling this concept here. Okay. So depends on that, it is going to be vary. So it's standard 8 megahertz microamps, and high drives you can able to give 25 microamps. Analog characteristics, the resolutions 12 bits, and conversion rates 0.41 microsecond. It is going to be converting that the analog to digital conversion is going to happen. And input impedance we need to be give of 50 kilohertz, and offset error plus or minus LSP. Okay. And finally, it is EMC characteristics, and that's it. The noise immunity we are going to be calculating. So this characteristic, we simply, if we need to get this all those data means no, not exactly. Okay, so we need to be give the data. We need to be mainly get the data of what is the input and in output pins. Power supply, analog pin power supply, and how it is actually working with the CPU different power consumption. So you need to be understood that concept. Okay. And finally, the package information. Okay, what does mean by package informations? Here you can get the package informations, complete detail of this. If you're trying to build, if you're trying to design one this package, okay, wafer package, what is this is the dimension. So you're going to measure with the dimension. If you're trying to draw the footprint, what you're going to you have to take the measurements from here, because the you can easily draw the schematic library easily. That is not going to be the matter. But if you want to be draw the footprint for this IC, you need to collect all the measurement data. Okay, what is the measurement of this one? All the data you can get it from here. So A means, for example, first of all, I need to be measure the data of this line. Okay, this is having the total measurements. You need to be find it out. Yeah. Give me a minute. Yeah, so it is having the total length, which is they have been mentioned in the value called as an E. So if you are taking a millimeter or meter inches, that is completely we are going to be do on PCB. So if you are drawn millimeter, you are going to be take the value called as a, so minimum value you can give the 3.150, and maximum that is, and typically you are going to be give this value. So you can give this measurement. So you are going to be draw like this, and you are going to be draw this value, and each and every ball size, everything you are going to be make sure based on the measurement you are going to be utilize this. If you are draw the complete chip by yourself, you're going to be draw the footprints, you're going to be taken this measurement from here. Okay, and then you're going to be pad size and all. Okay, so what is the pad size you're going to be give? What is the pitch size you're going to be provide? Everything they have been given. And if you're trying to draw the ultra fine quad plat package, so this is how you're going to be draw for each and every pin size they have been given as a data. And this is for ultra quad flat package size, and you're trying to be rather low quad flat package. So this is how the pin size measurements they have been given. Okay, you're going to be utilize the sizes at all. Okay, and finally it is a ultra quad low fine quad flat packages of 100 pins, same sizes, everything they have been given in the measurement size. Okay, each and everything, guys, what is the pin size, what is the whole size you are going to be put. Okay, so what is this? They have been each pin, this top size, they have been mentioned in the P. Okay, and if you just look out this one, what is the this distance? What is the distance of this one? And what is the distance of these two pins? So every data you can able the distance of these two pins, you can get the value of it. The measurements and all you can get through this data from here. Okay, so that is the pin package size. You might be designed with a different package like the package, ball grid array, or ultra fine quad flat package, kind of different package you might be designed. Okay, based on your application which is required. So why those packages? Why need to be go with those packages is the means you might be saw it is a through hole array. So the packages it is comes under the dual package. So we are having a SIP and DIP. So SIP means single inline packages. What it is? Single inline packages. If you are having a pins like this. If you are seeing a voltage regulator, some sensor which is having like this. This is chip and this is how the pins will be. This is called as a SIP. If you are having a very less pins, if you are having some high pins but not some you need to be connected some average kind of pins, you can use this dip packages. Okay, it is easy and it is a through hole, easy for prototyping. And a PGA, so ball grid array, means whenever you are going to be use this IC, high performance high density IC. Okay, so the ball grid array, the ICs are represented in ball size. ICs are represented in ball size only. So the complexity of board you want to be created, you just use this ball grid array. Then quad flat package. Okay, where size is easy to assemble. Okay, there is no complications is going to be happen here because your chip, your pins are located at the 4 end. Okay, you want to be reducing the IC pin size, you can able to simply put it on the 4 side, you can able to arranging your pins. Okay, we are also having ultra fine quad flat package. That means it is ultra quad flat package whenever we are going to be creating a chip for space, and that time we need to be require the more pins in it. For that we are just using the ultra fine quad flat packages. And the pin count and pitch, so we can get the data. We already studied this, right? So we can able to get the pin size and data from here. It is completely telling about the what is the pin size and what is the each pin sizes, between the distance and everything, you can able to get it from here. Okay, so that is a quad profile quad flat package, the full form is. Okay, and finally we are going to be discuss about the peripheral features. So yes, so these are the features you can able to implement it on this uh, controller and application information. So this is the last one we are going to be discuss about this. We have been discuss about all those characteristics. Okay, here yeah we are having a packaging information we have been completed, and finally ordering scheme. Okay, if you are having a different type of microcontroller series, mostly it is called as an STM32. Okay, ST microelectronic designed this. So that's what it is, STM32. It is based on this ARM Cortex based microcontroller. ARM Cortex means inside this microcontroller, we are having what chip? Processor core, right? We are having the core of the processor core. We are having the ARM processor core, which is having the size of 32-bit processor. That's what it is comes. The name was came like 32, STM32. Okay, so ST microelectronic was designed. It is STM. Okay, 32-bit. And EF witnesses, it is a general purpose. Whether you are going to be the what type of product you are going to be. Okay, whether it is going to be do the different applications, or you can able to do it because it is having ARM based processor. We can able to do the different application. I'm going to be using general purpose. Yeah. 411 means it is family. Which device family? We are having a different family, 508 or 101. So kind of different family it is indicating. And C means pin count. Okay, which pin count you are using? So I'm using a 48 to 49 pins I'm using. Okay, if you are using R means 64 pins, V means 100 pins. Okay, and then flash memory size. It's completely based on your XC and XC variant. If you are previously using XC variant, you will taking the memory size of 512 kilobytes. If you are using a C variant, you are having a 256 kilobytes. Okay, and finally package. Okay, package. Which package you are using? We are using this package we are actually using. Okay, WLC package we are using. That's what it is, why it is presented here. And temperature range. STM32, which can able to represent in which temperature range? 40 to 85 degrees Celsius. If you're using a different variant, it is going to be varies. I already told you, right? But STM32F411RE can able to work with this range of 40 to 85 degrees Celsius. And finally, the packing. Okay. So how you can able to pack that thing. So that's it, guys. Up to this, you will got clear on this point.